Okay, so here I am in Spartan time, and I'm sitting here with a student. She wants me to mention her name, Angie, and Stephen and Darrell are in here, and then one of my very favorite students, Jacob, is in here.
Favorite?
Yeah, I know, y'all are jealous. Okay, so we're going to look at the homework that's due on Monday. And Angie had some questions, and for the homework, I just want to remind you, you're supposed to do all of the odds in this packet. So I'm only going to do even problems.
What?
So you have to actually think about the odds. I know it's a little troubling. Okay, look at number 2. In number 2, and you might want to have with you your flip book, because you need to know this in order to do the problems. Okay? Now notice up here, we're working with parallelograms. If I were a student, I would underline that, because parallelograms means I'm only going to be working on this tab that's parallelograms. We could be using those quadrilateral formulas, but we're primarily going to be focusing on these properties of the parallelogram. What are my 5 properties of a parallelogram? Opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other, opposite sides are congruent, and consecutive angles are supplementary. Those are my 5 properties of a parallelogram. So when I look at number 2 here, what are we talking about in this picture? Are we talking about sides, or are we talking about angles? Well, I see that little degree symbol, so that means we're talking about this angle and this angle, which is the distance between those 2 lines. What do you notice about those angles? Are they opposite of each other in the parallelogram? Which means, are they in corners? Remember, sometimes I'll throw up my geometry gang signs. Are they in corners that are like here where my fingers are? Are they opposite ends? These 2 are not. This would be an opposite angle of x, but 76 is not opposite of x. So they would be consecutive angles. And consecutive angles are what? Well, look at your property thing.
Yeah, let me check it right now.
Consecutive angles are what? 1 and 2 here are consecutive angles, and they are?
Congruent? Or, no, sorry.
Consecutive angles, it's written up on the paper, up on the board. 180. They're
well,
supplementary.
Yeah,
she had her finger pointed to it.
So, these consecutive angles are supplementary. So how do I set up an equation like that? I would say 76 degrees plus x degrees equals what?
180.
180 degrees. Very good. And then you would solve for x. I think you can handle that, correct?
No. I'm playing.
Okay. So 1 and 3, if you'll look at those, Angie, look at these 2 problems.
Oh, you said my name again.
Are they consecutive, both of them?
No. The 1 is consecutive.
Okay.
But 3 isn't consecutive. Yeah, it is. Yeah,
they are. It's just down on the bottom instead up on the side. Right. So it's the same kind of problem for both of those.
Okay.
Okay. So I'm going to jump to 5. Don't do them right now. You can go back to them. Okay. But let's go to 5 here. Well, actually, I'm going to go to 6 because I'm not doing the odds, because there's only 2 problems here. Now, they want us to find the variables, and they're saying DG. This side right here is 4A, and this side over here is 5A minus 6.
Where do you see that? Oh.
My finger's on it, and I'm writing right on the picture. I might have to zoom out a little bit from it so we can see it. Much to Annie's disappointment, because now it's not going to be as big. But so we know that this side is 4A and this side is 5A minus 6, right? And then DE, which is this top side, notice we're naming it with 2 letters, and GF is 2A plus 8. Now, I might, if I were a new student with parallelograms, I might go look at my picture, and I might say, okay, what am I talking about here? Sides, right?
Yeah.
What do I know about the sides of parallelograms?
Sides.
I know they're parallel.
Yeah.
And I also know they are?
Opposite sides, congruent.
They're congruent. So I know that this side is congruent to this side, and it's parallel, right?
Yeah.
We also know that this side is congruent to this side, and it's parallel, right? We know all of that.
Yeah.
So, do you see anything that's congruent here?
What's equal to each other?
Yeah. Oh, You sound like an equation. You said congruent equal to each other. So if I have two pieces that are congruent, then that's my equation. So what's one of the two equations?
If they're congruent, why aren't they the same on both sides?
Well, that's a great question. If this were, they're congruent, right?
Yeah.
If this were 4a and this were 4a, what would happen when I solved that?
They'd both be the same number.
I would get equal to 0.
Oh.
Because 4a equals 4a would equal 0 would equal 0. And so we can't do math like that. So often they're going to give you a different set of variables to give you the same answer. For example, 4 times 5 is 20. But 19 plus 1 is 22, correct? So it's just kind of looking at different ways to come to the same answer. So here, let's say this is one equation. We could say that 4a equals 5a minus 6. I had two congruent parts. I said they were equal. Do I have to do the other congruent parts?
No.
Because once I find a, can't I just substitute in and find the length of that other side?
Yes.
Yeah. And that's what, they want us to do here. So what is a?
Wait, how do you do it? Wait, don't you just have to get it to the other side?
Yeah, we just want to get a by itself. How am I going to do that?
I don't... Oh, plus 6.
Okay, if I add 6, I'm going to be moving it over here, right? Okay.
Yeah.
Why do you want to do that?
To get that other by
6 plus 4a equals 5a. Now what do you want to do?
And then you do 5 plus 4, no, 5 plus 5, 10a.
Then I'm going to have nothing over here.
Oh, wait.
Okay, remember your first rule. Circle what you want to know. I want to get this a by itself, right?
Yeah.
Or we could get that a by itself, but I want an a alone. So my goal is to get that by itself.
5 minus 4.
Okay, you want to subtract 4a on both sides?
Yeah.
So I know 6 equals a.
Oh.
You could have done the same thing here,
Oh.
but it's fine. Worked out just fine. So we know in this problem that a equals 6. And 5 is the same kind of problem, and we're just looking at sides again. You see, it's not that hard. You just have to remember what the properties are so that you know where your congruent pieces are. So looking at these two problems, these are very similar to what we have just done up here at the top. This 8 is like these problems up here, isn't it?
Yeah.
Aren't these consecutive angles?
Yeah.
So if I add them together, they equal 180. Well, look at this one. What is this problem like? These that we just did.
Yeah.
So where do you have two sides that are congruent here?
The up and down.
This up and this down, right. And so that's your equation. B plus 14.5 equals 20.5.
What about that other side? 3b minus 6?
All you're going to do once you find B, you just plug it in and you find the answer.
What do you mean?
Substitute.
So once I get my answer,
Like
I
we
plug
found, but we found this was 6, right?
in. Yeah.
Can you tell me how long this side is? Or this side?
6.
I take the 6 and
Oh,
I plug
and
it
you
in for
plug it
A.
in.
Remember, we do that. We substitute the value we found for our variable in to the expression.
I still don't get that part.
Well, this would be 4 times what? What's my A value?
6.
So what's 4 times 6?
24.
It's 24.
So all
So I
sides
know
are
this side is 24.
Oh,
What
yeah.
other piece is 24?
You could do 3 parentheses 6.
Well, no, look. Our congruent symbols tell us what else is 24.
Oh.
I know when I
right.
plug a 6 in here, because that's my variable.
Yeah, it equals
This
20.
is 30 minus 6, which is 24 too.
The top is 20.
Did you plug 6 in there?
Yeah.
Yeah, and so this is 20, which I hope this is 20. If we did it right, it would
Yeah.
come out as 20. So 2 times 6 is 12.
Yeah.
12 plus 8 is 20. So those are, so we know we did the math right,
Okay.
if it all comes out. Same kind of thing down here for 7, but to find this side, once you find out what B equals,
So it would just
you're
be
going to substitute it
B
in.
plus 14.5 equals.
Put your sides that are congruent, right?
Wait, what?
You said it. B plus 14.5,
Equals
20.5. Okay? How what?
Oh. Does that mean you would want B alone?
Yep.
Oh, okay.
We always want the variable by itself. Okay?
Wait, then how would 8 work? So would that just be you put these, the two numbers, and then you equal 180?
Since we're not doing that one,
Yeah, I know.
let's do it together. We would know that these guys equal 180. You're exactly right, because they are
okay.
consecutive angles.
Alright.
So we would say 8s plus 5 plus 3s plus 10 would equal 180. And then you'd combine your like terms.
Okay.
You could solve that, I think.
Yeah.
Okay. Alright, so now let's look here at 9. What is 9 talking about? Think about what you know about parallelograms. What is he talking? These diagonal lines, right?
Yeah.
So looking at our properties of parallelograms, what do we know about diagonals?
They're bisect.
The diagonals bisect each other, okay? So that means that this equals this, and this equals this. Where do you have two parts that are equal?
The 2h and the h plus 5.
And that's your equation. You would say 2h equals h plus 5, and then solve it.
Okay.
Okay? Looking down here at these parallel lines, we talked about this a while ago, but I want to kind of hit it again. Each of these sections is going to be congruent, because all of my lines are parallel. Let me get back on the picture. All of these lines are parallel.
Yeah.
So this transversal is cut equally. And so this piece is going to equal this piece, it's just going to equal this piece.
But how is it equal? Because like there's only one line that's straight.
The transversal is straight?
Yeah, that one line that you highlighted.
Just on this line, all the pieces are cut equally.
Like that one side, or?
This line is a different line, right?
Yeah.
So each time it's cut, so from here to here, it says it's 6.5. So that means from here to here is 6.5. And from here to here is 6.5.
Oh.
Do you see that?
Yeah.
And then we have a third line. I'm getting another color, sorry. We have this third line, and they tell me from here to here is 5.75.
So from that.
So from here to here is 5.75.
Yeah.
From here to here is 5.75.
So can you do an odd or an even?
Well, it says what is EB? I think you know. See if you can't think what EB is. Number 11. Now what are we looking at? What color line? EB is on this blue line, right? So it's on the blue line.
05?
Right.
Oh, okay.
And AF is on what color line?
Where do you see AF? Oh, AF. No. I see AE. Oh.
AF.
Would it be 6.5?
Yep.
But, oh, never mind.
Good.
Okay.
And then CD is on what color line?
That straight line.
CD is on what color line? Blue, green. This is
blue, yeah.
red, and green. So it's on the blue.
Could be 5. Right?
Yep.
Okay.
Now, look over here at these. What would BD be?
Where is B?
From B to D.
Where do you see B? I see B.
Here, B to D. From B to D. How long is that piece?
Oh. Can't you just add that?
Yeah. How long would it be?
So it'd be like B. So it'd be like 10?
Yeah.
Oh,
So it's not hard, right? You got it?
Yeah.
Okay, that's all that is. In number 17, you better draw yourself a parallelogram. Doesn't have to be a perfect one, okay? They tell me that the length of one side of a parallelogram
Wait, where do you
is...
see 17?
It's the word problem at the bottom.
Oh, okay.
The length of one side, so I'm going to underline that, of a parallelogram. So we're talking about one side is 3 more. What does 3 more mean?
What is the length?
Plus 3. That's what 3 more means.
So it'd be 6?
We're not done.